All right, so today we're going to take a look at an example with arrow diagrams of both how to use an arrow diagram to evaluate an expression at a particular point, and we'll see along the way that it also reveals a student's thinking about order of operations as they work on that. So, start with, we'll make the arrow diagram for the expression. Always starts with the input variable, which is a D. By order of operations, the next thing that should be happening is a squaring of that function. That's my old notation. I'll come back in here and fix this. So squaring gives us the d squared, and then it's a multiplication by -2. That would give us the -2d squared. And then we should be adding 4. And then dividing that by 5 should give the final expression. So if we want to evaluate this now, I guess we'll make the comments right now that if student misunderstands the order of operations, then the arrows won't show up in this particular order that we have set up here. Okay? And you'll be able to see in a way that you wouldn't normally be able to see exactly where they are getting things backward and where the misunderstanding is. I know on this problem in particular, in a traditional case, a lot of my kids would do -2 times -3 and get a 6 before they then squared that and added 4 and divided by 5. And so they would get 36 plus 4 is 40 over 5, and they would evaluate this as an 8. Not an uncommon mistake to see along the way there. So what we're actually going to do here now is, since this is an input to output relationship and they ask us to input a -3, we'll start right here with the -3. It says square that, so -3 times -3 is 9. It says multiply that by -2, that is -18. And when we add 4 onto that, we get -14, divide that by 5, and we get -14/5 as the actual correct answer for that one. The other example that I showed earlier, we'll just kind of look through that to begin with, would have involved the kid, first of all, assuming that the first step is to multiply by -2 and then to square, then to add 4, and finally divide by 5. And you can see in the arrow diagrams exactly what they got backwards along the way. So that's just a simple example of how we can use, or of a particular use for arrow diagrams in revealing understanding of order of operations and also for evaluating functions.